Okay guys, today we are going to solve this limit. First of all, we need to know that pi is larger than e. We know that pi is approximately 3.14 blah 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 and e is 2.718. I guess it's bigger, so we can say that pi is larger than e, so what are we going to do here? As we know that both numbers are positive. Here we get 0, we get e, we get pi. We know that we need to do this, and pi is the greater. So what I'm going to do next, both sides I'm going to put n. Here we get e to the power of n, here we get pi to the power of n, right? Is this what we get? So here it's 0, here it's still the same, like this, it's still the same. What is next now? We are going to add. As we see here, we have e to the power of n, here we have e to the power of n, but we need pi of n, pi to the power of n. So we are going to do something really cool. Both every single side we are going to put e to the power of n. 0 plus e to the power of n it's still the same. Here we get e to the power of n plus pi to the power of n is less than pi to the power of n plus pi to the power of n. So what do we get here? It's pi to the power of n. Here we can just switch, there's no problem. We get this. Here we get 2 pi to the power of n. So see that now we have this square here, square root n. So what are we going to do? We are going to do same thing. Here we get this n square, this, and then we get this, and remembering that n is bigger than 0, so that everything here is correct. If we could see that n is greater than 0, so we get this. What do we get next? Yeah, it's n. Here 2 pi to the power of n, right? Here we can cancel out this and this, we get pi, and it's less than, and here pi to the power of n plus n e to the power of n, so it's less than. So this and this we can cancel out, we get pi. Then this doesn't have n to the n as exponent, so we get 2 over 1 to the power of 1 over n. So if we plug in limits both sides, here n, when it goes to infinity, pi here, which goes to infinity, so we get this pi e, we get this, then it's this, and when it goes to infinity, 2 to the power of n times pi. Here it's a constant pi. So what we get? Wait a sec. Okay, we get pi. It's less than, because here we don't have n here. So this limit when n goes to infinity, n this plus e to the power of n. Great. So if we plug a limit 1 over infinity, it tends to 1. So 2 to the power of 0, it's 1. So then we get pi. So we can see that we get pi from both sides. So we can say that this limit here, it's equal to what? To pi. If you wanna prove this property,